Okay, computer science, unit 5 from the Barron's study book. This one's gonna feel a little less concrete, straightforward, black and white kind of answers as most of the other units. It's more like different, some of it's more like philosophies for how we program, things like that. So, um, we'll try our best. I think there's less of these kinds of questions on multiple choice on computer science. Some of these ideas are just ideas that we just use to write good programs. So I'm going to go ahead and go over the questions you have. I think I'm just going to go in order and kind of go quickly through the ones that didn't seem to have many questions, and maybe take my time a little more on the ones that do. Um, So let's see. All right. A program that reads a 5-digit identification number is to be written. The specification does not state whether 0 can be entered as a first digit. The programmer should write a code to accept 0 as a first digit, since 0 is a valid input. That seems reasonable. Write the code to reject 0. I don't know. It doesn't say. So I don't eliminate 0 as a possibility. No. Treat the identification number as a 4-digit number. If users enter the number starting with 0, I don't think that sounds good. Check with the writer of the specification whether 0 is acceptable. Yeah, maybe you should check, with the person who's telling you what your job is. So, okay. So that just seems kind of maybe almost more, common sense. Okay. Number 2, refer to the following 3 program descriptions. Test whether there exists at least one 3-digit integer whose value equals the sum of the squares of its digits. Read a 3-digit code and check if it is valid according to a given formula. Passwords consist of 3 digits and 3 capital letters in any order. Read in a password and check if there are any repeated characters. For which of the following preceding program descriptions would a 3-digit number class be suitable? 3-digit number class. Well, the first one says that you're looking for a 3-digit integer whose value equals the sum of its square of its digits, which could be a method within it. And let's see. That one seems good. Read a 3-digit code number. That seems good. The other one has digits and letters mixed in, so I don't think that one's as good. So I would say 1 and 2. All right. Number 3, top-down programming is illustrated by which of the following? So by the way, top-down is when you sort of look at the big picture and start to develop the big picture before you develop the details. Writing a program from top to bottom in Java. That sounds like you're trying to interpret that literally. Writing an essay describing how the program will work and without including Java code. I don't know about an essay. Using driver programs to test all the methods in the order that they're called in the program. So that's the testing phase at the end. Writing and testing the lowest level functions first and then combining them. Well, that seems like bottom up, right? You're going to do the lowest level stuff and then make the bigger stuff. Writing program in terms of the operations to be performed and then refining these operations more detail. So you want to do sort of the big picture stuff and then tackle the details later. Number 4, which of the following should influence? I don't know why my light's so not bright. Okay. Let's see. Number 4, which of the following should influence your choice of a particular algorithm? Runtime? Yeah, that seems like a good choice, right? Memory requirements? That seems relevant. The ease with which the logic of the algorithm can be understood? That's good. Other people can understand your programs. I'd say all 3. Sound like very good ideas. Number 5, a list of numbers is stored in a sorted array. It is required that the list be maintained in sorted order. This requirement leads to to inefficient execution for which of the following processes? So what is going to be inefficient because of it being needed to stay sorted? Summing the 5 smallest numbers in the list? No, because that's going to be easy because it's sorted, because they're all at the bottom. They're all at the beginning. Find the maximum value. That's going to be easy because it's at the top. I mean, these are things that are going to benefit from the sorted. Inserting and deleting numbers. Well, if you insert a number, you're going to have to shift everything down. If you delete a number, you're going to have to shift everything back. So this is probably the one that's going to be the thing that takes more effort because of that. So all right, sorry, give me 1 second to get organized. I guess I could pause the video on. I'll do that next time. Or we could just, Okay. Which of the following is not necessarily a feature of a robust program? Now, a robust program means that generally the term robust, we saw at the beginning of the year, means something that can work on other computers and not have to be changed to work on different computers. That's one of the reasons that Java is considered robust, because it has its own JVM, Java Virtual Machine, that gets installed on any computer, so you don't have to change the code to work for a different type of operating system. Does not allow execution to proceed with invalid data. That's so which of the following is not necessarily a feature of a robust? Not a feature. So one of them is not a feature. Which of the following is not necessarily... Okay, so it can allow execution to proceed with invalid data, so it doesn't crash. Uses algorithms to give correct answers for extreme data values, so it can deal with big numbers. Will run on any computer without modification. So I guess that what I was explaining was the wrong thing. Will not allow division by zero. Will anticipate types of errors that users of the program may make. Which of the following is not necessarily a feature? So I forget the term now that allows it to run on other computers. So robust is more that it'll run without, stopping in the middle for errors because of, things that maybe we can anticipate. C7, a certain freight company charges customers for shipping overseas according to the scale, $80 per ton for a weight of 10 tons or less, $40 per ton for each additional ton over 10 tons, but not exceeding 25, $30 per ton for each additional ton over 25. So you get a discount for the extra tons, right? This kind of makes sense. For example, the ship of weight 12 tons will cost 10 times 80 and 2 times 40. 26 will cost 10 times 80, 15 over 10 at 40, and then 1 over 25 at 30. A method takes as parameter an integer that represents the valid shipping weight and outputs the charge for the shipment. Which of the following is the smallest set of input values for shipping weights that will adequately test this method? So this is asking you, test your method thoroughly. Something that I asked you guys to do all the time, right? Was to try and test your methods, like all the different, important cases. So we probably want one that tests in the 0 to 10 range. Okay. Probably want one that tests in the 10 to 25 range, something between at something more than 10, but 10 to 25. So 11 to 25. So we want something probably 0 to 9, or 0 to 10, and then 11 to 25, and then 26 on. We probably might also test the 0 case specifically, because that's kind of a special case. So we want something in between here, something in between here, something in between here. We might also want to test the border cases. Okay. So I'm thinking 0, 5, 10, 15, 25, 30 looks like a good set of values. But hold on a second. I'm leaning towards that, but this is tricky. They said something. I don't know. I guess 0 shouldn't be a case because you really shouldn't be shipping 0 tons. So I guess 0 is, not a valid case. And it says that we're trying to, yeah. So that was kind of tricky. Otherwise, I'd go with D. Border cases, in between cases. Number 8, a code segment calculates the mean of values stored in integers n1, n2, n3, n4 and stores the result in average, which is of type double. What kind of error is caused by this statement? n1 plus n2 plus n plus 3 plus n4 divided by double 4. These are integers, okay? Now, you might think, let's see. Okay, so is there overflow would be too big of numbers. I don't think that's it. Syntax would be like you wrote something that won't compile. I don't think that's fine. Type mismatch, even though these are integers, you can divide by double, which will create a double and store it in a double. So no type mismatches. Runtime error would be like when you run it, you get some kind of error. I don't think the logic is that division has precedence over addition. So we actually need parentheses. Otherwise, this will get done first. The n divided by 4 will get done, and then we'll add that to 3, 2, and 1. So that's a logic error. So nothing bad happens. It gives you an answer. It just gives you the wrong answer. Okay. So you got to understand precedence is like order of operations. That's a fancy term for order of operations. Okay. Number 9, a program evaluates binary arithmetic expressions that are read from an input file. Binary would be 2. All of the operands are integers, and the only operators are plus, minus, multiplication, division. In writing the programmer forgot to include a test that checks whether the right-hand operand in a division expression equals 0. So they said, they forgot that right hand means this is left hand, this is right hand. Operand, they forgot to check that this is 0 because that gives you division by 0. When will this oversight be detected? Will it be detected at compile time? No, because we won't know if we're divided by 0 yet. Will it be detected by the computer when editing? No. As soon as the data from the input file is read? No. It'll depend. It'll happen when we try and divide by 0. During evaluation of the expression, when at least one incorrect value for the expressions is output. So it's going to happen when it tries to divide by 0. That kind of error is going to happen when they try to divide by 0. Otherwise, if the programmer put a check in there, then it just wouldn't happen at all. 10, which best describes the precondition of a method? Okay. It is an assertion that describes precisely the conditions that must be true at the time the method is called. It's what we assume to be true, I think. Initializes the parameters of the method, no. Describes the effect of the method on its postcondition, no. Precondition is something that's true at the beginning of a method. Explains what the method does, no. States what the initial values, no. It describes the conditions that must be true at the time the method is called. That's a precondition. And you see it in the code, in the comments, of different methods. Okay, 11. Consider the following code fragments. So we have precondition, A1, A2, A3 are distinct integers, meaning they're all different integers for sure. Postcondition describes to you what's going to happen. That max will contain the largest of those numbers. And so this is a comment. First set max equal to the larger of A1, A2. So we look for the max of A1, A2 and set that to max. And if A1 is bigger than A2, it's the max. Otherwise, A2 is the max. And then we compare that max to the third number. And if it's lower than A3, then the max is updated to A3. If it's not, we don't need to do anything because it is the max is what it's supposed to be. For this algorithm, which of the following initial setups for A1, A2, A3 will cause the least number of computer operations, best case, to the greatest number of computer operations, worst case. So they're looking for best and worst case scenarios for how many, computations are made by the computer. So we're looking for what's going to result in the least number of things for your program to do to get to the answer. And then the other case is the opposite, worst case. So we want, I think that it'd be good if A1 or A2, probably that A1 is the max. That's probably the best case scenario. Or A2. So least number, largest value is, and we're looking for the largest value, so definitely want largest value. Largest value, I think, is an A1 or A2 because this doesn't take, if this is true, it does this, else it does this. I think that's the same number. And then it's going to check this, but it's not going to do this step. So that saves you that step. So I'd say A1 or A2. Largest value is an A1 or A2. Largest value is an A1 or A2. Now, the worst case scenario would be that the largest value is an A3, right? That's for sure the worst case scenario. Largest value is an A3. It doesn't, yeah. So I guess another way of describing the largest values in A1, A3 would be the smallest value is in A3, which was not an option here, but that could be an alternative way of describing that situation. Let's see. Number 3, refer to the following, or number 12, compute the mean of the integers 1 through n. N is an integer that is greater than or equal to 1 and has been initialized. Int k equals 1, double mean. So we're initializing, creating some variables. K is 1. You have the mean. You have the sum is 1.0. Those are both doubles, while k is less than n. So I think k is kind of like a counter. So it's kind of like a for loop, but we're using a while loop to do it. So k is like a counter starting at 1. And while k is less than n, the number of integers, so n is the total number we need to check, then do something. And after we're done, we're going to set the mean equal to the sum divided by n. So, I mean, just looking at this, I'm not even looking at the question yet. I think that we would probably do like sum plus equals. Now it's weird that the sum was set to 1 to start with. Compute the mean of the integers. Okay, so I mean we're adding all those integers. So I guess we've already set the sum equal to 1, and that would be like k equals 0. So it's like k equals 0 is already done. And we're not going to go to or equals n, the last number. So we're going to, I think we do k plus plus first, and then sum plus equals k, because we already did k equals 1. So we're going to increment it. The last one that's going to be done is going to be k equals n minus 1. So we want to add that in, so we increment it, and then we update the sum. What is the precondition for the while loop? the precondition for the while loop is that k is greater than or equal to n. No, precondition for the while loop. I think it's less than n, and the sum equals 1.0. The first time, I guess, okay, the sum will equal all of these. Not yet. Or, yeah, every time we do the while loop, this will be true so far. And k will be less than n until it's equal to it, and the sum will equal 1, just at first, but I don't know, this one's kind of confusing. Let's see. Precondition for the while loop. Just before the loop is executed. So I'm assuming, is it before it's executed the very first time? Because then it's in the middle of it. So I think sum equals 1 has to be true. K is going to be, k has to be less than or equal to n, I feel like. Because maybe there's only one number. Maybe n equals 1, and so then k already equals n. So I think k could be less than or equal to n, not greater than n. That doesn't make sense, because then n would have to be 0, and it says that n has to be greater than or equal to 1. So there's no way n cannot be 0. So I think this one's out. The sum of these numbers up to k, I don't know. Let's see. K is less than or equal to n, I think I need to say here. N is greater than or equal to 1 for sure. That they stated that k equals 1 for sure. And okay, so this is more like, these are all the things they told you were true. Now the mean hasn't even happened yet, so that's for sure out. And I think this one was wrong because it has to be or equal to. And that one's wrong because it has to be less than or equal to. And this one, we haven't added anything yet until we hit the loop. So that was kind of a tough one, I think, to think about. 13, the sequence of Fibonacci numbers. Fibonacci. So sorry, I was going to pause this. I didn't. Okay. Let's see. Okay, sequence of Fibonacci numbers. Now, Fibonacci, the next number, the first two numbers are 1 and 1, and then the next number is the previous two numbers added up, and then the next number is the previous two numbers added up. So the next number is always the previous two numbers added up after the first two numbers are set as 1 and 1. So n has to be greater than or equal to 1. The nth Fibonacci number is going to be returned. This is a public method. It returns an int. It's static because we're not going to create any actual objects of this class type. Its name is fib. It takes an argument of int. The previous value is set to 1, and then the next value is set to 1, and then the sum is set to 1 to start with. So for int I equals 3, so we're starting at the third number, go all the way up to n, increment it as we go. There's it says assertion. Which of the following is the correct assertion about the loop variable I? Okay, so sum equals next plus previous, and then so it adds the previous two, next and previous, and then it updates the previous to be the new next. What was the second one becomes the first one, and then next equals the sum. And then it doesn't, oh, okay, yeah, next becomes, sum is the new number, so next becomes the new number. Which of the following is correct about assertion about the loop variable I? I starts at 3, by the way, right? Inside this loop, what is true about I? Well, it's definitely not greater than or equal to 1 or 0. It could be equal to 3. It starts at 3. So I'd say greater than or equal to 3 and less than or equal to n. So I'm thinking C makes the most sense, right? It can be 3 and it can go all the way up to n. Now, at the end of the for loop, it gets incremented. So 14, refer to the following method. Precondition A and B are initialized integers, public static int mystery. That's the name of the method. Takes 2 ints. It has a total called 0. Count equals 1. While count is less than or equal to B, update the total, add the A value. So it looks like, just quick, I like to maybe avoid looking at the questions right away and try and just understand the code. We're starting count equals 1. And so, like, as an example, let's say that this was like 3 to 7. 3 and 7. What it's doing is it's saying total equals 3, right? And count is 1, and it's comparing it to 7. So then we add 3 again, 6, and then we add 3 again, 9, and then we add 3 again until we get up to 7, and then we're done. So it's going to it adds 3 for 1, 2, 3, 4, 5, 6, 7. So it's going to add 3 7 times. 3, 6, 9, 12, 15, 18, 21. And then what is it doing? In other words, I think what it's doing is it's doing A times B is what it's accomplishing. A times B. What's the post condition? What is true when you're done? Okay. Let's see. 15. A program is to be written that prints an invoice for a small store. A copy of the invoice will be given to the customer and will display a list of items, quantity, unit price, total price, and amount due. These 3 candidate classes for this program are invoice, item list, where item is a single item purchased. Item list is a list of all the items purchased. Which class is a reasonable choice to be responsible for the amount due method? Which returns the amount customer dues. So the amount due is for the total price of everything. So I don't think item should have it for sure. Item list could have it. I think invoice could totally have it, and item list could have it. So it's not, but item really shouldn't have that. That's a single item. So I'd say 2 and 3. Number 16, which is a false statement about classes in object-oriented programming design, which is a false statement. If a class C1 has an instance variable whose type is another class C2, then C1 has a C2. Yes, that's the has a relationship. That's class composition. If a class C1 is associated with another class C2, then C1 depends on C2 for its implementation. So associated means that it uses it, and so it depends on C2 for its implementation. That almost, if class C1 is associated with another class C2, then C1 depends on C2 for its implementation. Let's see. I don't know. Let's keep going. If classes C1 and C2 are related such that C1 is a C2, C1 is a C2, that's C1 is a C2. So this is a superclass and a subclass, then C2 has a C1. No. It doesn't mean that there's class composition. So that one seems false right now. If class C1 is independent, then none of its methods will have parameters that are objects of other classes. Independent, meaning it doesn't, I guess, use any other, doesn't require any other classes to be given to it. Classes that have common methods do not necessarily define an inheritance relationship. Common methods, it might be an interface. You could link the common methods through inheritance, but it could be an interface. So I think I'm going to go with this one. This is the most obvious false statement, that if you have an is a relationship, then you also have to have, if C1 is a C2, then C2 has to have C1. That's not true. Okay, 17. Java program maintains a large database of vehicles and parts for car dealerships. Some of the classes in the program are vehicle, car, truck, tire, circle, steering wheel, and airbook. The declarations show the relationship between classes, which is a poor choice. So these are kind of hard because it's not like it's not a wrong choice. It's just maybe not a great choice. I don't know. So public class vehicle, you might have an array of tires and a steering wheel. Okay, does the vehicle have those things? A tire extends circle. So it inherits methods from the circle, like superclass. So a tire is a circle. Yeah, okay. Class, a car extends vehicle. Yeah, a car is a specific type of vehicle. So this is good. This seems good. Public class tire has a rating and then has a boundary that's a circle. These seem like, I guess, this seems okay. Steering wheel has an airbag and a circle boundary. Okay. So I think this is the one that makes the least sense, that a tire is literally a circle. No, it has circle qualities about it, but it also has other things, like it's not a specific type of circle, right? Anyways. Okay, 18. A Java programmer has completed a preliminary design for a large program. The programmer has developed a list of classes, determined methods for each class, established relationships between the classes, and written an outline for each class. Which classes should be implemented first? Superclasses? Subclasses? I don't think you would do subclasses before superclasses, because subclasses, you want to reuse the code from superclasses. All collaborative classes that will be used to implement other classes. So those would be kind of like the kind of helper classes, like low-level stuff. The class that represents the dominant object in the program. Maybe all independent classes that have no references to other classes. So this is the choice, because what happens is independent classes have work without the other classes that you're working with. And so then we can test these on their own and then build the other classes. And implement it means, we're not saying like, we've already figured out the rough idea. Now we're going to start writing the code. So it's better to write the code for the classes that can be tested on their own. And then you'll know that those are already done. And then you start to write the code for the other classes that use those ones. But now you don't have to worry that code is wrong. Use the program description below for questions 19 and 21. A program is to be written that simulates bumper cars in a video game. The cars move in a square grid and are located at grid points X, Y, where X and Y are integers negative 20 and 20. The bumper car moves in a random direction, either left, right, up, or down. If it reaches a boundary, then it reverses direction. If it is about to collide with another bumper car, it reverses direction. Your program should be able to add bumper cars and run the simulation. One step of the simulation allows each car in the grid to move. One step, each car moves. After a bumper car has reversed direction twice, its turn is over and the next car goes to move. Okay, so I guess one car keeps moving until it's reversed twice, and then the next car goes. To identify classes in the program, the nouns in the specification are listed as program, bumper car, grid, grid point, integer, direction, boundary, and simulation. So these are just different things that are on this. How many nouns in the list should immediately be discarded because they are unsuitable as classes? So just because we've listed all these things that are in the program, which ones should we not really make as its own class? Program is kind of vague. I think we should have bumper cars. Should we have, and this is immediately. So it doesn't mean that other ones shouldn't be maybe removed later, but program and integer. We don't need a class for integers. That's just a type of value that we're going to be using. So I guess it's those two. It's kind of hard. It's kind of vague. It's kind of subjective. So some of these questions are like that. A program decides to include the following classes in the program. Refer to them for questions 2021. Simulation, to run simulation. That's the driver. Display, which will show the state of the game. So that's a display class that is responsible for showing you the status of the game. Bumper car with its own identification number, position in the grid, and current direction when moving. Grid point is a class. Will be the position in the grid. It will represent two integer fields, x coordinate and y coordinate. A grid itself is all the grid points. We'll keep track of all the bumper cars in the game, number of cars, positions, grid. It'll update the grid each time the car moves. It will be implemented with two-dimensional array of bumper car objects. Which operation should not be responsible? It should not be the responsibility of the grid point class. So grid point is a specific grid. Is empty. Returns false if grid point contains a bumper car or true otherwise. That sounds reasonable. It's at the boundary. Is a grid point at the boundary? Maybe. Left. If not at left boundary, change grid position to 1 unit left of grid point. What should not be the responsibility of a grid point? If not at the top grid, change top of the grid, change grid position by 1 unit above the current point. So this is just saying move it to the left, move it up, return the x coordinate of this point. That seems like it should be. It's like a getter. So a grid point is just the position in the grid. It doesn't really know anything about if there's a bumper car there. The grid keeps check of where the bumper cars are. And so that would be, I guess, the thing we should get rid of. It doesn't know if it has a car. Again, it's kind of hard. Okay, 21. Which method is not suitable for the bumper car class? So, which of these should not be a method in the bumper car class? So, 4 of them should sound good. At boundary. Returns true if the bumper car is at the boundary. False if otherwise. Select random direction. Bumper car could select reverse direction. We could reverse direction of the bumper car. We can move the bumper car. Update. Modify grid to reflect new position after each stage of move. So I guess this is the one. Again, I don't know. That we shouldn't use. All the other things, public void update, modify the grid to reflect the new position. So that sounds like something for the grid class. So that's it.